This is our second attempt at the buzzer and bulb circuit. So let's just recap. That's what we tried, and we found that although the buzzer sounds, the light bulb doesn't light up. So some electricity is definitely flowing through it, but the effect of having them connected in series, one following the other, is that although the buzzer gets sufficient electricity to buzz, the bulb doesn't. So there's not enough there to light it up, although it is flowing. So there's got to be an alternative, and of course the wires can be moved from one place to another, and by rearranging them we've come up with this, which looks rather complex compared to our simple series circuit. But what it's done is create a divide. These connections here, you can see why the word parallel might be used to describe them, sort of lined up, but such that the electricity from the battery can actually flow through the bulb, and by taking this path it isn't interfered with in any way by what's happening to the buzzer. So it's as if the battery quite happily has a simple circuit with the bulb, but at the same time this branch in the parallel circuit allows the buzzer to obtain exactly the right amount of electricity, as if it was there on its own. I mean, it's not as if the buzzer and the bulb know that each other are there. All that we're concerned with these conducting wires is that we give the components, the buzzer and the bulb separately, sufficient electricity by having a straight through connection to the battery. So a parallel circuit is a great way to ensure that devices like bulbs and buzzers can get the amount of electricity they require. And it won't be the same. The buzzer will still take a small electric current, the lamp will take a larger electric current, and really these currents form the total current flowing in the circuit. So that's our parallel circuit. There it goes. Let's turn it on. And there you can see the lamp lights up nice and brightly, and the buzzer still sounds as before. So a parallel circuit ensures that the separate components obtain the correct current flow of electricity to light them up or make them sound as you would expect if it was just there on its own. So what does that look like when we try and draw it? Well, it does become a little bit more complicated, and you can get a bit mixed up with this, but let's have a look. The circuit I've drawn there looks like the sort of parallel part is going in a different direction. But there are so many ways we can draw it, yet it is the same thing. So here we've got our little branch, allowing the electricity to flow by two different routes. And here we've got our little branch allowing the electricity to flow by two different routes. And we could draw it another way as well. Look, we could just say, well, what's the point in that line there? Why don't we just simplify it by doing this? Look. And that is exactly the same circuit as well. It has the branch, it allows the electricity to flow, by two different parallel paths. So parallel circuits and series circuits, we now know the difference. Fantastic.